All right, so here we got a question. There's a lot of details in it. So I'm going to kind of write stuff down as I go through it. This is the way I like to think about these problems. Sure helps me. So got a medication, it's being tested. Often when we have a medication, that means we're going to want to do a treatment control situation. If this works. So subjects, there's looks like two groups. They were volunteered to take part of experiment. So we got the first group, 160, was randomly assigned to receive the placebo, and 280 received the medicine. So those are my two groups. I got placebo and then treatment. Placebo is often called the control group. So that was 170. That'll be N1. And the treatment, we'll call that N2, 280. Okay. And then it looks like high pressure disappeared in 80% of the controls. So of these, sorry, in 80 of the controls, 80 of those had high blood pressure go away. So that'll be P1 hat. 80 out of 170 had their low blood pressure go away. And then it looks like 170 of the treatment. So 172 over 280 is the treatment. That'll be called P2 hat. Okay. So I'm just going to type that information and kind of double check my work. N1 is 170, P1. I'm going to just ignore the hat. That's my first proportion. That'll be my treatment or my control group. Then my treatment group is 172. Sorry, 280 total. And P1 is 172 people had their blood pressure resolved to P2. Okay, so that's kind of the base information. So let's check what our hypotheses are. The null hypothesis is there's no difference between the two groups. So we're going to say that P1, this is in the population, is no different than P2. That's the general hypothesis. Sorry, it is equal. It is equal to P2. No difference. P1, P2 equals 0. And we want to test the claim, I haven't read this part yet, that the blood pressure is effective. So effective means this group is going to have a higher rate. So I'm going to want to say that P1, that P1 is going to be less than P2. So the proportion of people in this treatment group that have an improvement of their condition is better. Okay. So to proceed, we now need to take into account the fact that this null hypothesis, we're going to assume it's true. So if that's true, we're going to assume these two proportions are coming from the same group. So I'm going to find my pool proportion. So that's going to be the total number of successes. So 80 in the first group plus 280 in the second group divided by the total number of people. Looks like 170 plus 280. So successes divided by total number of cases. And I'm going to use that to calculate my SE now. So the SE for this pooled group is pool proportion times 1 minus that divided by N1. So that's the variance for the success of the first group. And then I'll say the pool proportion, I like to align this, 1 minus pool proportion divided by the size of the second group. So that's just the formula. You can also copy paste that from before. So I'm gonna check out what that variance is, run these two chunks. Or standard error. That's my standard error. So what I can say now is that this difference between the two proportions has this standard error. And if I want to use my test statistic approach, this is the Z value. I'm going to say Z is the observed difference of proportions. What is the observed difference? So I take P1 minus P2. That's the actual difference. minus the null difference. I'm going to write this out. This is kind of the formula for all z statistics. So the test statistic z is your observed data minus the null over your standard error. So the observed data is my P1 minus P2. The null, in this case, the null value for P1 minus P2 is going to be equal to 0. So I don't have to subtract that, or I could say minus 0 if I liked, and then I'll divide by my standard error. That'll give me my z statistic. Okay, so that means 3 standard deviations to the left. That sounds pretty significant. Let's see how much. So if I draw my distribution here, here's my z distribution, has middle 0, standard error 1, and I am 3 to the left, 2, 3. So I'm pretty far to the left. So whatever this value is here, I want to find that value of anything more extreme. So it looks like I'm going to find the lower tail of that. So to find that, oh, here's my test statistic. I can already put it in here. So to find my p-value for that test statistic, that'll be p norm of z, and it's standardized, so I don't have to say 0, 1, although I could if I wanted. And that's my p-value. It's pretty small. So what does this tell us? P-value getting so small, kick h naught out the door. So this means, since this value is small, I'm going to reject the null. I have evidence of the alternative, which says that P1 is less than P2. I have evidence that this treatment is helping people lower their blood pressure. So we'll reject the null hypothesis. We will reject the null and say that there is enough evidence to support the claim that new beta blocking medicine is effective. So we have evidence to support this claim since we rejected the null. And now I'll check my work, make sure it all checks out. Ooh, looks like I made a mistake. Let's go see if I can check my work here. Check my numbers. So 170 is the number of control subjects, placebo, yep. Over, ooh, look. 170 is that group, 280 received the medicine, 80 controlled, 172 in the treatment group. So I made a mistake here. We got 80 and 172 in the treatment. Made that mistake. So these are the number of 80 plus 172. That's the number of people that had decreases in blood pressure. Yeah, high blood pressure disappeared. So now I'll recalculate my SE, and I'll recalculate my Z and my p-value. Okay, so my p-value is still significant, but what's my Z value? -2. So it looks like I was off because of a missing number. There we go. Got it. All right, I hope that helps. We'll see you.